Hi everyone. In this presentation, we will be completing chapter 6.1 in the OpenStax Intermediate Algebra textbook. This chapter is the greatest common factor and factor by grouping chapter. And specifically, we will be looking at the third learning objective, the final learning objective, factor by grouping. Now, if I look at the textbook itself, we are again in chapter 6.1. We're looking at the final learning objective, factor by grouping. You can find the two previous learning objectives in prior videos. If I scroll down to the section you're looking at, you're looking for the subheading, factor by grouping, which includes some chapter reading along with examples and some practice problems. And then if you scroll down to section 6.1 exercises, and down to factor by grouping, you will look at some similar problems we are going to cover in this video, questions 37 through 50. Those are the similar type of problems we'll be looking at. All right, so let's go ahead and get started. So what is factoring by grouping? So factoring by grouping is a method for factoring polynomials by making two smaller groups first. So for example, let's take the polynomial x squared plus 5x plus 3x plus 15, and let's start by grouping the initial terms together. So I'm going to group the x squared plus 5x, and I'll group 3x plus 15. Now what we're going to look at is we're going to factor out the greatest common factor of the x squared plus 5x term and the 3x plus 15 term. So let's first do the x squared plus 5x. So x squared, if we expand this out, is x times x. And the 5x term is 5 times x. Now the greatest common factor, or the common factor here, is just the x terms. So in other words, for the first parentheses, I should say, we're going to factor out our x term here. That goes in the outside of our parentheses. Again, we're doing the reverse distributive property here. And then on the inside, we have x, right? X times x is x squared. Plus, if I was to then do 5x divided by x, I would just get the number 5. So this first parentheses is x times x, or x squared, plus x times 5, which is 5x. All right, so that's the first grouping. Let's go ahead and look at the second parentheses here. So the second parentheses, then I have 3x, which is really 3 times x. And then I have 15, which is really 3 times 5. Now the common factor in this case is just the number 3. So the number 3 then is the greatest common factor. So the second parentheses, then, I'm going to put 3 on the outside of the parentheses. 3x divided by 3 is then just x. And then the second term is really 15 divided by 3, which is 5. In other words, if I was to check my work and I did 3x times x, or 3 times x, I should say, I get 3x, and 3 times 5 is 15. Okay, so now I've done the reverse distributive property. From here, you will factor the common binomial that you see. Well, here, do you see that the common parentheses in each is our x plus 5? So factoring our common binomial means that we take the x plus 5 part, that becomes our first parentheses, and then the two terms that are on the outside of the parentheses, being x and 3, we then put as our other term here. So the x plus 3 goes on the outside, or I should say on the inside of the parentheses. Okay, and this is our answer. So our answer in this case becomes x plus 5 times x plus 3. The big idea here is after grouping, the parentheses should match. X plus 5 is our matching items here. So now let's go ahead and solve a few questions with some specific steps defined. So our polynomial we will be factoring is going to be m squared minus m plus 6m minus 6. I'm going to give some scratch work on the side here. So step number 1, we are going to group terms with common factors. Well, the m squared and the m have common factors, the common factor being m, and then the 6m and the 6 have common factors, that being the 6. We are then, step 2, going to factor out the common factor in each group. So starting with m squared minus m, if I was to go over here and define, okay, what is that greatest common factor here? We have m squared, which is m times m, and we have m itself, which is just m. So in other words, the common factor is a variable. So we could say really the GCF of this first group is m. So then when I factor that common factor from the expression, we would put m on the outside of the parentheses, and then we would have m times m on the inside, right? M times m is m squared. And then this is a little interesting. So negative m, what would I put here? Well, if I was to do m divided by m, that's like the same number divided by the same number, you would get 1. So we actually need to put 1 here in the parentheses. Now, if I check my work here, m times m is m squared. M times negative 1 is negative 1m. The 1 in front is irrelevant information, so you could just write that as m. So this is a correct way of doing the reverse distribution of this particular factor. Okay. Now let's look at the second set. So the second set we have is 6m minus 6. So again, if I look at the second set, we have 6 times m, and then the 6 is just the number 6. So the common factor here, if I was to do GCF, is a number 6 here. Okay, so 6 then goes on the outside of the parentheses, and on the inside of the parentheses would be, if I did 6m divided by 6, the letter I end up with is m, minus 6 divided by 6 is also 1. So now I have m parentheses m minus 1 plus 6 parentheses m minus 1. Now we're going to factor that common factor from that expression, which in this case is going to be the m minus 1. So that becomes the first parentheses. And the second parentheses then is going to be the m and the 6. So I would write that as simply m plus 6 here. And we are finished. Now, if you wanted to check by multiplying the factors, you could. So essentially, in this case, you would use what's called the FOIL method. So you would do first m times m. M times m is m squared. Then you would do the outer. So FOIL is first, then the outer, which is going to be m times 6, which is 6m. Then you would do, let me go ahead and erase this so you can see it. Then we would do the inner, which is negative 1 times m. So that would be negative 1m. And then we would do last, which is negative 1 times positive 6, which is negative 6. So if you then go look up here, basically we could reorder the two middle items and we'd have m squared minus, you could have 1m or you could just label as m plus 6m minus 6. So this is checking our work, and we've realized that, okay, this answer that we arrived at, m minus 1 parentheses m plus 6, if I was to actually multiply through using the FOIL method, we do end up getting our original starting spot. So that is question number 1. Let's take a look at question 2. So factor by grouping the polynomial 2a squared plus 10a plus 3a plus 15. Again, I'm going to group things that have common factors, which happen to be the first and the second pair. So then I'm going to look at the greatest common factor of each. So if I look at 2a squared, this is really just 2 times A times A. And then if I looked at 10A, this would be 2 times 5 times A. And I realized that the common factor would be 2 and 2. And we also have some A terms, so A and A. So in other words, the greatest common factor for this one is equal to 2A. So I can factor out a 2A for that first parentheses. I get 2A on the outside, and then on the inside would be another A, right? 2A times A would be 2A squared. Plus 10A divided by 2A would be, so 10 divided by 2 is 5, A divided by A is just 1, so we would put a 5 in its place. Okay? So that is the first parentheses there. Let's look at the second parentheses in this case. So let's factor it out. So we have 3A, which can be labeled as 3 times A. And then 15 can be labeled as 3 times 5. So the common factor in this case is just the 3 and the 3. That is our GCF, greatest common factor, is our 3. So then at this point we can write this as plus 3 on the outside of the parentheses, and then A plus 5 on the inside, right? 3 times A is 3A, 3 times 5 is 15. Okay, so now notice that we have that common binomial, the A plus 5, A plus 5. So that then becomes our first parentheses, A plus 5. And then the numbers on the outside, 2A and 3, become the numbers on the other, inside the other parentheses, I should say. So A plus 5, parentheses 2A plus 3. That is our answer. Now, if we wanted to check our work, we could multiply our factors by using the FOIL method, which I'll go ahead and define a little bit more clearly than last time. So FOIL is first, outer, inner, last. So if we did the first, that would be A times 2A, or I could write 2A times A, which is 2A squared. Outer is going to be A times 3, which we could flip it around to where the number is the coefficient in front, so 3A. Inner then is going to be 2A times 5, or 5 times 2, however you'd like to write it, which becomes 10A. And then the last is 5 times 3, which is equal to 15. So now I have all my terms. If you look up here, those are the terms that are indeed there. If I was to rewrite it, it would be 2A squared. If I put the 10A first, I could put 10A here, plus 3A, plus 15. And that again shows that our answer matches if I was to expand it back out to the actual polynomial form. That's question 2. So looking at question 3 then, we have the polynomial 4x squared minus 8x plus 3x minus 6. So step 1, group terms with common factors. So the 4x squared and the 8x have common factors. 3x and 6 also have common factors, so we can group those together. Then let's go ahead and factor out the common factor in each group. So if I look at 4x squared and 8x, and I did the prime factorization here, we would have 2 times x times x. And then the 8x can be 2 times 2 is 4 times 2 is 8 times x. We see that 2 2's are basically covered, right? So we'd have this 2 and this 2 and this 2 and this 2. So those 2 2's. And then we also have an x term. Okay, badly drawn circles there, apologies. But basically our GCF then is going to be 2 times x, which is equal to 4x. Okay, so that is our greatest common factor for the first term groups. Okay, so if I go and actually take that factor out of the parentheses, what I then get is 4x on the outside times x on the inside. 4x times x is 4x squared. And then I would have minus 2 on the inside, right? 4x times 2, 4 times 2 is 8. Have the other x, so 8x there. Let's look at the next term then. We have 3x and we have 6. So 3x is simply just 3 times x, and 6 is going to be 2 times 3. So the only common term then that I have in both is our number 3. So that's what we're factoring out of the parentheses. So I put 3 on the outside. I would put x on the inside, right? 3 times x is 3x. And then 3 times 2 gives me 6. So from here, we have a common binomial that we can factor out, right? We see the x minus 2 on this parentheses, x minus 2 over here. So then x minus 2 becomes our first factor, and then we have 4x and 3 that we put in the other parentheses. And this is our answer. If I went to check my work, step 4, check by multiplying the factors. Again, we can use the FOIL method to check. So we would do x times 4x. Oops, 4, we'll do that. 4x times x, which is equal to 4x squared. We do the outer, which is x times 3, or x times 3, I should say, which is equal to 3x. I'll switch the order where the coefficient 3 is first. Inner then is going to be your 2 times x. Or excuse me, 2 times 4x, I should say, which equals 8x. And then we have our, and this is also a negative 2, so negative x. And then we have a negative 2 times 3. That's the last. And we would get negative 6. Okay, so now we can group all of our terms. We have 4x squared minus 8x plus 3x minus 6. And this matches up to our original. So that is question number 3. So question 4, we have the polynomial 6y squared plus 9y minus 4y minus 6. We're going to group terms with common factors. Again, 6y squared and 9y do have common factors, so do 4y and 6. So 6y squared to start. Let's find the greatest common factor here. So this is going to be 2 times 3 times y times y. And then 9y is going to be 3 times 3 times y. And we notice that we have a 3 and a 3 that are covered, and a y that are covered. So our greatest common factor for each is going to be equal to 3y here. Okay, so 3y is the first parentheses that we can factor out. So going to that first parentheses then, I can put 3y on the outside of the parentheses. This is then going to be multiplied by 2y, right? 3 times 2 is 6, y times y is y squared, plus 3. 3 times 3 is 9, y times just kind of no y, or y times 1, I should say, is y. That's correct. So 3y parentheses 2y plus 3 is the first parentheses with a reverse distribution applied. Let's go to the next parentheses then. We have 4y minus 6. So 4y can be 2 times 2 times y. Should put a minus there too. There's a minus really. And then a minus 6 is going to be our 2 times 3. Now looking at our common terms, the only common one is a 2 here. Okay. So at this point then, we're going to factor out a 2. Make sure to put the minus there. 2 times 2y gives us our negative 4y. And then the 2 times, in this case, it's going to be positive 3 because we have a minus 6 there. So negative 2 times 3 is negative 6. So we get a plus 3 on the inside. So now what we have is 3y parentheses 2y plus 3 minus 2 parentheses 2y plus 3. Notice that it has that common binomial that we can then factor out. So the 2y plus 3 is the first parentheses. And then the 3y minus 2 is our second parentheses. And that is our answer. Again, we can check our work using the FOIL method. So our first check is going to be the first two terms, 2y times 3y, which becomes 6y squared. That confirms this first term up here. The outer is 2y times negative 2, which gives us negative 4y. The inner then is 3 times 3y, which is equal to 9y. And then the last term is going to be positive 3 times negative 2, which is negative 6. So if I then combine all of them, 6y squared plus 9y, if I skipped it and kind of matched it up here, minus 4y minus 6. So that checks off our work here, checks off our work there. All right, so 2y plus 3 in one parentheses times 3y minus 2 in the other parentheses is our result. The final question for this presentation is the following, where we have two variables connected together, x, y, plus 4x plus 2y plus 8. But the process is basically the same here. We're going to first group our terms that have common factors. So the xy plus the 4x. So let's go ahead and start up here first. So xy is really just x times y. And then the 4x is going to be 2 times 2 times x. The term that matches is our x terms. So that's our GCF. Greatest common factor is x. So going up to our first parentheses, we can put x on the outside of the parentheses. And on the inside, we then have y plus 4. Okay. If I was to do x times y, that's xy. X times 4 is 4x. Let's go ahead and look at the next set of terms, 2y and 8. So 2y is simply just 2 times y. And 8 is going to be 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Notice our common terms then is our 2 and our 2. So this is the greatest common factor then for 2y and 8 is a number 2. That then goes on the outside of the parentheses, 2. And what goes on the inside is y plus, so 2 times y is 2y. And then 2 times 4 is 8. Oops. Sorry, guys. Don't know what I was writing there. 2 times 4 is here. Okay. Now, our binomials that we have are the y plus 4 and the y plus 4. That is going to be the first parentheses then. And the second parentheses will be the terms on the outside, the x and the 2. So that is x plus 2. Okay, and this is our result for question 5. Now, to check our work, again, we can check by multiplying the factors. Specifically, we can use the FOIL method, first, outer, inner, last, to do this. So first is going to be the y times x, or x times y, if we're going to follow the structure from above. So that's xy. The outer then is y times 2, which we can write as 2y. The inner, which can be written as 4 times x, so equals 4x. And then the last, which is going to be 4 times 2, which is equal to 8. So then if I rewrote all of this, this is going to be xy plus, let's kind of follow the structure again. We can try 4x plus 2y plus 8. So we have confirmed that this particular factor can equal this from above. All right, so that is question number 5. So those are our core practice problems for the presentation. Now, if you'd like to confirm your understanding, we have the following questions that you can find in this presentation's guided notes. So I'd go ahead and take a shot at each of these questions. You can then confirm it with the answer key on the backside of the guided notes. If you have any follow-up questions, feel free to write a question in the comments. Good luck, and I'll see you in the next video.